Hello everyone and welcome to this month's Patreon. First of all, I will show you some wireframes. So what we will do, we will create basically like particle vellum grain advection with Pyro and then run a grain simulation or vellum grain simulation after that. You can also do that with pop grains. And yeah, here are some style frames I just did. And we will dive right into it. So discard. And you can see here currently in Octane, we will do Octane and the Redshift setup. We can zoom in really nicely and we got a lot of detail. So I think that's pretty cool and can play around with it. So what we will do is we will start with the normal setup and then Octane and then with look dev. For the version, I'm currently on Octane 2024 Alpha 4. And the version is 2024.1. The plugin version is 1.4.0. It's from April. Yeah. And Redshift, I'm currently on 3.604. And Houdini version is 19.5 or 640. I'm currently not at 20.5 at the newest version because yeah, somehow scalability and somehow stable wise, because the last few months I was on a lot of client projects and yeah, 19.5 did the job really well. And I think there are also some freeze issues with Octane regarding specific graphic cards and but yeah, let's see when we will get a new studio driver or something like that. Okay, this is basically I played a lot around with like different setup, but then I just like used the setup from a client project. Beat that. And now we can start. I will give you just like, I think a quick rundown would be cool. So we'll start with a simple match size here, but just to get a platform. Scatter some points, rasterize density and position, creating a little pyrosource and then a pyrosolver, and we will create this little pyro simulation. And we can then use that pyro simulation to basically advect our particles. So that's the cool thing. Another cool thing is that we use basically a VDB from polygons as a collider, and we will also like import our point velocities. So what you can do, you can basically get anything in here, which is pretty cool. Yeah, let that whole thing. What I did was just like a simple circle here, transformed a few times. Scaled up, get a point velocity. Also did some curl noise on it. And it's basically it, and then scaled or added as a multiplier if I need to scale like the velocity. And then the same thing here, simple box, vellum grains, like 3 or 4 million, I don't know. Random selection, this is for shading, so we can use our little rand attribute for shading to get those shimmery particles. Yeah, and then basically caching that thing out. And let's disable the velocity here. And after that, I got a little library. You can choose whatever you want. I just got like a few stones here, hydro stones, and what I did is just poly reduce them, and then you can see we will go for each through them. So you can see we've got 4 different. And that's the main thing, that those are not connected and have a connectivity attribute, because we will need that to basically make a little variance library. And then what we will do, we will copy each different instance to our point. And that's basically it. And it's also basically the same for that Redshift. To do this would then just be a proxy. We can do that. Okay, cool. But now let's just do the setup. Okay, what we will need. What we will need is a box. Let's place down a box here. And what I want to do is to do like roughly the same size. So I'm currently working in like a 1-to-1 environment. So I think that's pretty fun. So let's do like 2 by 2 and a height of 0.1. And then I did like a circle. Of course, you can go with other, I would say, starting or initial like sources or initial volumes, initial geometries. What you also could do, could play like, for example, with a product or with, I don't know, a skull, a landscape, and so on, and convert that into smoke, and then you have a really nice starting layer. So I think that would be also nice. Could do that, by the way. Why not? Let's just go for a mountain here, and what I want to do is just do it that way. Let's just subdivide that, but be linear. What I want to do is just a bunch of resolution, or we even don't need. Let's just go VDB from polygons and go 0.01, because then we have like a more interesting star base. VDB. That polygons. And then what we can do is get a point warp down. Displays along normal. And then, for example, an anti-alias noise. That in here, pipe that in here. And a normal, get a constant. Vector. Positive y direction, and then we can play with scale. And we've got ourselves like a really fast, simple escape. And we can then use that basically for our, first of all, for our smoke initialization, but we can also use it for our group. So I think maybe we can make it a little bit smaller now. So what I will do is just scale it down. But let's just keep that. And we can scale it down for the value train if we. So this will be, let's place a null here. This will be in for smoke. And what I want to do, I don't even need to match size now. What I want to do, I want to place down a. Okay, now we've got our info smoke, and we need to basically rasterize this thing here, which is pretty easy. So we'll need a point from volume. And you see the density of the points is way too low. So we will pipe it up 0.0, I don't know, 5. That should 0.5. 2 million, 3 million, perfect. And what we then can do is get the pyrosource, initialize smoke, and if you want, you can also initialize velocity. Will not work with that. And let's get a point separation to 0.01. And then a volume rasterize attributes. Voxel size also 0.01. And then we will rasterize the position and the density. And we are basically set. So we've got roughly 600,000 voxels here. Of course, we can dial that a little bit. 900,000. I think that's fully fine. Let's just play a little bit with the jitter scale here, so we get away from the stepping. But I think something like that should be full. Then we need a pyrosolver, of course. This will be just a really simple pyrosolver with a few adjustments. So what we will need for this will be our just tag it source. In source. And what we will need is something that will advect our, and this is like basically the thing. But first of all, let's place down a pyrosolver. And I want to just like get that started, and the voxel size would be like 0.01, and the collision we will set it up. So the collision will be SDF plus volume velocity. And what we will do is go on the quick setup tab here and then set up SDF collision. And you will get already this little VDB from polygons with the right VDB name, basically velocity. It's a displacement velocity acceleration vector type with a point attribute of v, so that will be rasterized and will be stored as a velocity. Then for like sourcing, etc., we'll not need a lot here, so we like disable those two, because we will not need temperature or flame. For the fields, what I did here, I basically disabled dissipation. So we'll do the 2 and disable flame. What we could do, for example, for shape, we could enable viscosity, get a little bit of viscous smoke. But what I want to do is to enable disturbance and turbulence, get just a little bit of I will go for here for 0.1 and turbulence 0.05. And the threshold field, we could use, yep, this, or we could temperature. But let's just go for density now. Advanced, I think I did not care. I think that's basically it. Of course you can play around with that, but for just a simple advect sim, you don't. Okay, let's just try that out quickly with a simple sphere. So I will get a sphere here. And what I want to do is to polygon, and I want to make it smaller. And I want to move that off center. And then for the Y rotation, we could use $F. So it's now basically rotating. Could multiply that by 2, so it's a little bit faster. Let's go by 4. And then we'll pipe that in here. And if we now, like a really so low, but if we now do a really low res sim here, you can see that we've got our little collision sphere here. And let's just go for 0. And you can see our sphere will, yeah, basically collide and advect, but we need point velocity. And what I want to do is to compute basically the velocity of the sphere, of course. This is the velocity. But I also want to introduce a little bit of curl noise. Thanks. So now we see like an actual advance. Of course, this is super low res. Let's make it a little bit more high res here. And make it also faster, ×8. Could move the sphere a little bit down, or we can just elongate it a little. And let's wait a bit. But you can also already see we've got nice advection going on behind the sphere. You can also really nicely use the setup to get more of a kind of an aesthetic collision in, for example, like a sand bed or like a powder bed, etc. And then just use this thing as, so basically use this thing here as your initial vellum grain sim, which we will also do later, but then zero out of gravity and just use the volume advection to get the move. Yeah, you can see we've got here a nice little pyro or collision. Now we can make this, of course, a little bit more fancy. We can go further with the sphere, why not? But what I want to do is to get I did it with a circle. So let's just get a circle again. But in that time I want to like squish it a little bit. And why not also bend it? Set capture region. Let's just bend our circle. And twist it. And then what I want to do is get a transform. And after that transform, a copy and transform. And then a sweep. A little sweep node. Perfect. And then around. And what I want to do is to a little bit smaller, a little bit higher resolution here. I think it's just a collider or an advection collider, but I want a little bit more segments here, so it will look a little bit more nicer. And we did the infinity sign. Perfect. And then what we can do, we can copy that a few times, scale it down, like maybe, I think that should, and then rotate it. And the cool thing is we can then rotate it via frame. So $f times 6.18, and the other direction would 2.5 or 2.5, and the last axis would be, I don't know, 11.11. And it's maybe a little bit too fast. So let's just remove here a 1. And here a 3. That should be fine. And what we then basically can do, we can copy the values and alternate them in here a bit. And we will got something like a strange rotating easy thing. Perfect. For organization purpose, what we can do is just up here in collider, oops, double L, and now what? 8 million voxels. Okay, that's not that bad. Let's go a little bit lower. And I think we already get some really cool advection going. And here again. And I think we can also frame that nicely. Of course, also down here. So don't forget, we've got then 2 sides. Or what you also could do is get a sphere, for example, as a initial volume. I think that would be also really cool. And then what I said earlier, we could introduce a little bit of viscosity. So we get a much like smoother representation of that now. Which looks also, I think, pretty cool. But I want this kind more of a shredded look. So I will this terms a little bit up. And then what we will do is to place a file cache. And I will rename that cache pyro effect 001. And I will cache that out on like, I don't know, 0.01 or 0.0085 or something like that. Because that's fully fine. So I will press the cache button and I will see you in a second. Hello and welcome back. So my simulation is finished. I think it looks pretty cool. Especially in like 130 to 100, I don't know, 60, 70 frame rate. I also like the early frames with those rising things. And what I did a simple retime to just like basically this animation here, which is pretty fast in my opinion. 10 times slower, so just retime output frame range 1 to 2400, input frame range 1 to 240, and then just get, that's important, to interpolate between input frames. Here you can use just the linear or cubic subdivision interpolation, whatever works best for you. And now we are here with our smoke sim. So we can start now with our vellum grain stuff. What I want to do, I want to get this null here copied. And I want to like get a smaller portion of it. Maybe also like a circle. So what we can do, we can just like extract that quickly. I want a circle, so let's go for a tube here. And this tube will determine my intersection radius basically. I will go a little bit higher with the columns to just get a clean cutout, and then a simple boolean. We will change the boolean here from subtract to intersect. Type that here and here. And we will get this sweet little, I think that looks funny, that sweet little intersection. The cool thing is, it's of course procedural, so you can go up and down how you want it, or you could grab like a specific portion. So if you don't want to cut out the middle, you can just move it, and for example, let's just get that one here, and yeah, then you will end up with this kind of portion. So I think that's pretty cool, and of course Boolean model with ReDB remeshing, and especially like with an exercise remesher or the newest remesher in the 20.5 version, I think that's pretty cool to work with. Okay, we've got our Boolean. Now what we need are basically vellum grains, vellum solver, advection, random selection, etc. So what I want to do is to get, this will be in for source vellum. Let's just label that. And then vellum grains, pipe that out. Breakpoints from volume, adjust radius to avoid overlap, and then let's have a look. I think that's fine. And I want to jitter the surface like a little bit. You can do it, you don't need to do it. You can also just go for the jitter scale to get rid of the stepping. If you like the stepping, I think it's sometimes pretty cool. You can use that, of course, totally up to you. And I want more resolution. So that's now 1 million points. Let's go a little bit lower. See how that will look. 4 million. I want roughly like 3 million. 2 million. Let's go to 5. But I think 0.004 will do the job here. Let's see. Yeah, 3.09 million. Cool. And now what we can do, or what I want to do, is to introduce this little section. I want to get a random selection. And with that random selection, I want to create a group called selected here. I want to randomize the element order. And, oh no, get a ratio here. This ratio, let's just make it red or black. I think black is pretty. This ratio here will determine your shimmery or shiny particles. You can dial that up, then you will get a lot. But I want to get them like in a fairly low density. So for example, something like 0.28. You can also see that here. If I want like 10% around, then it would be something like that. So it would be roughly 300,000 shiny particles. And I think that's an okay amount, but I want to go a little bit lower. So I want like 5%. So 0.05, roughly around 150,000 particles selected. And then I want to give them an attribute. So we can use that in shading. And let's just call them selected equals 1. This attribute will get applied, if you have a look here, every particle, but we want to just the selected group. So we now have basically our selected attribute here. Let's make that better visible, like that. We got now our selected attribute on our selected points. Now what we can do is place down a vellum solver, pipe that into here, get to frame 1, and we can basically start with our simulation. So what we need to do is to basically vect our particles with the pyro cache here. So just copy the null here, and this will be out at vect pyro 001. And what I want to do is dive in here, get an advect 5 volumes, and just press Shift W in my case, or you can also get it via the selector here. And what I want to do is just get the out advect pyro right in here, update velocity, and then to get a little bit of imperfection, what I want to do is to get the pop wind, like maybe an amplitude from 0 to 0.1 and a swirl size of 0.05. And then what we also need to do is to ramp up maybe 1 or 2 substeps, could be fine. But I think 1 substep is fine. Disable gravity. And then that should be fully fine. Now what we can do is again get a file cache. And this will be our cache out grains 001. And now we can run that. So this is our grain simulation. This will be advected by our pyro force velocity field. And let's see if it will work. let's just go for a little lower resolution. Copy. Go for, I don't know, 0.01. And let's see if it works. And yes, it will work. Looking good so far. And now let's pump up the resolution here again and cache that out. And after that's finished, I will see you in a bit. Hello everyone and welcome back. So the grain sim is finished. It took about, I don't know, 5 or 6 minutes. And I think we've got some really nice thingies going on here. What I could do is to just get another point velocity quickly and calculate the speed and show the speed. Where's it? Hidden a speed here. And let's go for another representation. Fine. Nice, yeah. Okay, that's some really cool forms here. Nice. So keep that in mind. You can just use something like a point velocity as a quick visualizer on to just simply see how, for example, this area look, because I find it pretty sometimes a little bit harder to see without any representation of speed or vector length. So that's cool, or of course then in rendering. Then what we need is a simple attribute wrangle with a p-scale randomizer, or you can just use code, you can use VOPs, you can use basically whatever you want. A randomization of the normal, and then a variance thing. Okay, let's just do that. So this will be our out BTS, for instance. Cool. Then what I want to do is to get a simple wrangle. This will be our set p-scale. And I got this little here. So you could just copy that, or you can use cut. Okay, and of course you can also use other methods to set the p-scale. You can use VOPs, you could use, for example, an attribute adjust float. This one here. So there are many possibilities. Then we need just a simple attribute randomize, and we will not randomize the color, we will randomize in a sphere. That's set direction or rotation. Nice. And then what we need is the library. So I already set that up. It's pretty easy. Just get yourself a few scans, or you can model own stones or whatever you basically like to copy. Those things does not need to be like stones or any other form. Of course, you can also use leaves or, I don't know, different chairs floating around. That's fully up to you. But this is my little setup here. And I will just show you quickly, like a quick way on how that would work. So for example, a box. We got a box, we've got a sphere, a simple sphere. We got a platonic solid, So those three then merged together. Then we will need a connectivity. And I will call this set rand underscore rand. And what I want to do is to get the set variance here. So what we need to do is to get a copy to points and then an attribute from pieces. This one. The left input will be the point cloud. The right input will be the content library. So for example, we want to copy 3 different pieces. The output will be again the target points to copy, and the left input will be again our content library. For Octane, we will need the material here between, so mat instance Octane. So this then will be our material. And then the piece attribute. We set that here, the set rand. And then we will copy that basically to our points. I forgot to click the pack and instance button. Oh no. Let's see how that will turn. I think that could take a little bit to copy an actual geometry. Okay, let's cancel that. And what I want to use is then, or what I want to click is then the packend instance. And you can see now we copied the things here. What we also can do to get like a quick glimpse is to make a blast. I do that all the time for like sizing, etc. To just get like a little portion, delete non-selected, pipe that into here, or just get a null to pipe it in. Copy the points, and you can see this mess here. Because what we need to set is the set rand, need to set that on the piece attribute. Set. And now you can see we've got a random geometry for each copy. And we can cycle through it. We could do patches with like noise. So I think that's also really, really cool. If you need to do that, if you want to do that. You could go for some, this would be a promotion method. I think the default is average. You could then shuffle the pieces between the patches. The distortion, there is a cool thing. Then noise, of course, is also nice. But I usually, for this kind of work, I will do it just random. And then it's just randomly copied over the points, which is pretty cool. And another nice thing is you can then just quickly add another, for example, a dodecahedron, and you can really extend your library. But I think for like a particle simulation, more kind of a grain macro shot environment, I think 3 to like 9 different geometries to copy will work really well to not get like repetitive geometry. And of course the size is also beneficial. Okay, then what I will do, I will just grab this one here. And this is basically the same, just with stones. So see, I will pipe that in here. And those little stones will get randomly copied. Now another thing, what I can do, I can adjust the P scale here a little bit better to like fit my geometries. So that would be like a 0.05 maybe. Or maybe like a little bit larger. Of course, we got a bounding box, or like basically the vellum collision. And I usually try to stay in that kind. What you also could do, you could go under Advanced tab, OpenCL. No, not OpenCL. It would be Grain Collision, and then assume uniform radius, make that off, and then you can dial in here a different radius for each point, but that will increase your simulation time a bit. Or not a bit, in some cases like pretty enormous. So that's fine. Now what we can do, we can just get like an attribute delete, for example, and we just need get the set rand, and got our selected attribute. Selected. Okay. And then let's get the null here. And this will be, oops, out. Will be for Octane. And I will show you Redshift. But now let's toggle the Octane thing. And disable the blast here. So what I then did is just instancing motion blurred computed from velocity attribute, get that in. And what I also want to basically get is, we've got our rand attribute that we created here, or our selected attribute basically. And what I want to do is to get that. Attribute in here. So what we will basically do, render as point cloud. So that is like a little bit faster to view, of course, and to go around in the viewport, make camera, light adjustment, etc. And then under Octane properties, this will be packed geoinstancing velocity attribute. And what I want to do, I want to import another point attribute. This will be called selected. And then we another material. Let's just copy this. Instance, let's call that instant tutorial. And what I want to do to get like a standard visualization here is just basically two materials, a material mixer, and I want to mix between those two with, I think it's a fairly new node, it's called texture instance color, and let's just call that selected. And I want to make one of those yellowish or orange. Selected. And then what we need to do is to dive in here and get our material in here. Then our material is applied to the instances. And we can dive up a level again. And now and get the selected one. can also get here. I just need to look again how I named that. Did I name it select or selected? Selected. Oh, it got a typo. That's why. Perfect. But we got it here. Yes. Selected. Okay, let's just view that one here. Copy attributes. No, wait. Oh, where's it selected? And it should be also here. Select. Because I currently can't see it. Maybe I'm just blind. Oh, there it is. Selected. Okay, perfect. It's there. Just thought I did a mistake. Okay. Selected. Okay, nice. Then I got a simple Octane light here and the Octane camera. Setup from Octane also as usual, just the normal thing. Path tracing, universal texture. I will not use the texture. I got a light here. The Octane light, but basically, let's just go get a camera view here. Material should be set. And what I want to do, I want to, okay, the occlusion, that's also fine. And let's start up our Octane render view here. This could take like a little bit of time to like load all the instances in. And there we go. And we forgot to, or we basically did a little error. We just mixed those two. Okay, so this will be white and this will. Now let's just reload our IPR and you should see that some of the that some of the little ones should be yellow. You can see it here in the bokeh. Let's just shift the focus here. Let's not shift the focus. Because those are like 5%. Just dive in here. And what I want to do. Get a little bit more depth of field here. And let's make just a quick full scene reload to be sure. Okay, am I blind or why does it work? The selected is in the mount. Let's just use a material diffuse. And let's have a look again. Okay, there's nothing to see. Let's just confirm again that the attribute is here. And it is there. All selected. Okay. I forgot something. I don't think. Let's just delete that one. And try it again. Okay, it does not work. So, hello and welcome back again. I had some time to figure it out. Currently, I think there's a bug in a specific version in Octane that you cannot use multiple instances and access the point attribute. So I just currently will use like one stone to copy. And it's weird because on my other setup it works. but when I restart it, it sometimes will not work. I think that's a bug. What I also did, I renamed the selected attribute to isolated points, and then just cast f at isolated equals integer at isolated points to just give a float value, because we need a float value to work with. Another thing that I did, I dropped that into a new container that you now can see what we need to toggle and to do for our material. Let me just get that away here. Okay, so now what we need to do is to first, let's just link our material here. So this will be material instance tutorial. So this is linked. And what I want to do, I want to dive up, and on the geometry node here, I want to get the object parameters. This will be packed geo-instancing and instancing computed from velocity attributes. MB will be motion blur, and then custom attributes on point. We click the plus, and then we will select the isolated. And assign, you currently see only one. That's because we need to enable that here or build it up quickly. So we will use a material mixer. Then the amount will be the texture instance color node. This is a new node. And this will be, let's just call it import mask. And then we need two materials. 1 minute. And then one orange and one, let's go for this color. And then what we need to do is to assign that one. And that should now work. Let's go in that camera. And now what we can do is hit IPR. And I already tested it, so now it should definitely work again. But I think there is already a newer version out there. Yes, okay. And now we can dive inside here and of course start with our look dev. So what I did, for example, because I got currently like one light, and what I want to do to get that a little bit faster here, under render point cloud, to get just that faster. And what I did, for example, let's just use a relatively nice frame. Something. This should be fine. Let's just use more of a close-up because I don't want to a lot of dark, because I like the light that way. What I want to do is get up the depth of field a bit, so I don't know, maybe 4, that should be fine. And what I then usually do for the other type, I would raise up the metalness. And you can, if you want to, include another color. I will raise up the specular roughness to 0.35 and then the specular IRR to 1.61. And then you can already see we've got our little cool shimmery particles here. And then I usually do that, like shimmery, that. And then my normal particles are usually a little bit darker. And now you can already see like the shimmery particles. For me, that's a little bit too much in my opinion. So what we can do, we can go down with the brightness of the material itself. Or what we also can do, so let's just go here where we see that nicely. So those are the shimmery particles. What you also can do, you can play a little bit with the roughness and also a minor impact there will be with the specular IRR. I find that 1.61 had like the best look in some cases, not in all cases, but you can play around with that. And then of course with base color. You can get really creative here, but I want to get it like a little bit more faded or not so shiny. And then you will end up with something like that. Now, of course, you can start with the look dev. So try out different lights, try out different materials. What I also really like is when we get an other color in here. For example, like a more sandy color. Add a little darker or a little bit brighter, up to you. And I think that also already looks pretty cool. So then can start with your look dev, and I think it's really fast and pretty nice. So I will clear that now, and then we will take a look and see how we can achieve the same thing in Redshift. Okay, now a workflow that I like a little bit more is Redshift. So in that particular case, I think Octane will improve over time, of course, and they both improve over time. But yeah, the battle of the render engines, basically. For Redshift, it's pretty straightforward in my opinion. Pretty cool. What I want to do, I got those little stones here. I think you already know them. I got 4, and in Redshift, I think there's currently no bug, or I mean, like in my version, especially with the kind of instancing workflow, and for example, the bug in Octane, that it will sometimes work, sometimes not. Sometimes it will work in a new geometry container, sometimes not. So I think this is a little bit of a pain, especially for good workflow, I would say. And yeah, I think in that case, Redshift is a little bit more stable. But I think enough talking here. You can also, of course, skip fast forward. But I need to get a little bit more time to let the last thing here run through. So I think we are done. Perfect. Okay. For each connected piece, and then what I want to do, single pass. So I got 1 stone here, and what I want to place down is a proxy, a Redshift proxy output. Let's get at. And what I want to do, archive, this will be a HIP file, and I want to make a new folder called proxy. This will be proxy, called just stone underscore 000 .rs. Discard not used attributes. Let's detoggle that and just render to disk. So that little, I don't know why, that little proxy is now rendered to disk, and we can do that for the other ones too. So that would be, okay, now it's fast. And 2, and then the last one, 3. So now you can see we have 4 different proxies here that we can use in our workflow. And that's pretty straightforward, which is pretty cool. We will just delete that and that. That too. Delete that too. And now we want a proxy. Redshift packed proxy. Oops, not the output, the file. And let's just import them. So proxy 001, 02, 3, and 4, 0, 1, 2, 3. And let's just get them here. 1, 2, and 3. And what we can do, we can import them here simply. I would say a mesh would be the bounding box would be like the best thing. And then we can just copy them. And now we basically successfully copied our little stones here to with the Redshift proxy workflow, which I think is sometimes or a lot of times way more better than. So, hello. We are back with the Redshift thing, and yeah, we need to get, or we want to get this rendered. I just isolated like a little thing to make it a little bit faster. Now, we did that setup here. We also placed our packed proxies geometries. And now what we need to do is to override the user data. We need to go to settings, and those are Redshift instances, and process instant and instance file attribute inside packed primitives. We need also that. And then we need to add our isolated attribute right here, and then it should work. So let's see if just that portion will work. Okay, we now got our rendering here, so that works fine. And now let's check if our user data will work. Color user data isolated, and that should also work. Yes, nice. Okay, what we could do is then, for example, just ramp that and a ramp, and go from this iteration. A little bit more brownish. And on those, let's just make them like that would be. And now let's disable that one and see if like the full big version also works. So this will be now roughly, I think, 3 million instances with round about, I don't know, 500, maybe 100 to 200 polygons per instance. It should take a bit to load that into Redshift. I think Octane is a little bit faster there, but you cannot load extremely high amount of instances into Octane. But they improved that also over time. But I think that should now load in, I don't know, maybe 1 minute or something like that. So you see under here loading objects, so that's a good sign. And that could take a little bit to load up all the proxies in there. So rendering is working now, but it was really slow to like calculate. And I think it could be the driver or the Redshift and Houdini version does not really match. I know that. But yeah, you can see we've got our different grain sizes. We got our little color imperfections or separations, and that's all working fine. So now I of course encourage you to play around with Redshift or Octane or even Karma, etc. Or you got another render engine, I don't know, maybe V-Ray, and is there another one? I don't know. RenderMan, maybe? And yeah, try it out, try different lights, different scattered objects, and so on. So I hope you liked it, and I will see you next month with the next Patreon tutorial.